Alright guys, this is section 4.2. We're going to be translating the graphs of sine and cosine. And what that means is we're going to be taking those basic sine and cosine graphs that we've been working with, and we're going to start moving them around a little bit. We've already experimented with playing with the amplitude and the period in section 4.1, but this time we're going to talk about shift, like in this case, our vertical shift. Now, I don't really know what's going to happen in these examples that we have down here. So I'm going to start right away with my calculator. And as you can see, I'm in radian mode, which is where I want to be. So let's go to our y equals screen. And the very first one, let's just graph the sine of x. Now something we want to be careful of is our window, because we know that our period is 2 pi and that it really only goes between -1 and 1. So our x min, we're gonna actually go with -1, so we can get a little bit past. And our x maximum, I'm gonna go with 2 pi. And our x scale, we're gonna go by pi over 2. So that we'll get those same graphs that we've been looking at in class. Our y minimum, we're gonna go with -1. And our y maximum, we're gonna go with 1. And our y scale is 1. So let's take a look at this graph. And what we should see is that basic sine curve that we've been talking about. Okay, what we're going to do now, we're going to zoom that window out just a little bit. So our x minimum, we're going to keep the same, as well as our x maximum. However, our y minimum, we're going to go -5 to 5. Okay, just to take a look at what this looks like now. So this is our basic sine graph one more time. And let's take that and put it over here. Now using that exact same window, let's type in a +2. Now what do we think is going to happen there? Well, it's a plus. So I think that might mean it's going to move the entire graph upward. And look at that. That's exactly what it did. So let's drag this guy down here. Now if we compare these graphs side by side, we want to notice a couple key points. Look at where the graph intersects the y-axis there versus over there. It went from 0 to 2. And that's just one very easy point to find. If we were to look at the entire graph, we'd notice that, yeah, the whole thing got shifted upward 2. So when we have a +2 tacked onto the end, we know that that will be an upward shift. All right. Now in this case, we're actually going to look at the cosine graph. So let's go back to our calculator. Let's just graph the basic cosine function. And again, I have my window set at -5 to 5 for the y values, and -1 to 2 pi for my x values. So there's my basic cosine graph. Now, what do we think is going to happen with this -3? Well, I knew from the previous one that a +2 shifted it upward 2, so I'm going to make the guess that a -3 is going to shift it downward 3. But just to check, let's take a look. So -3. And we graph it. And let's drag this graph over. Now once again, guys, a really good way to identify points is let's look where this graph intercepts the y-axis here. And from our previous findings, we know that that intercepts at y equals 1. We know that the cosine of 0 is 1. But take a look down here. That's now at y is at -2. So what's the change there? Well, we see that it has moved downward 3 units. So, our conclusion, we know that this one moved downward when there's a minus. So the vertical shift, it's the amount the graph is shifted up or down, and we can shift them up or down by adding a constant in the front or the back of the function. Okay, let's make it clear. The front or the back does not matter. If we take a look up here, the cosine of x minus 3 and minus 3 plus the cosine of x, or negative 3 plus the cosine of x, those are going to be the same thing. It does not matter where the 3 is in the front or the back. What does matter is that it is a negative 3 in both cases. And likewise, over here we've got 4 plus the sine of x. That could also be written as the sine of x plus 4, which is going to be a shift upward. So that was vertical shift. And now we are going to talk about horizontal shift, or left and right. And this is also known as a phase shift. So once again, let's get our calculator out. We just want to try and understand what's going on here. We don't need to break our heads just yet. So let's get a basic sine. Let's clear this function out. Basic sine of x graph. And again, we see that one that we're becoming very familiar with. This is our starting point. And now, let's take a look at inside the parentheses. Notice we want those to be inside. Sine of x plus, it's not 4, we want pi over 4. Well, this one didn't get any bigger or smaller and didn't move up or down. So let's pull it over here and see what happened. If we notice, just like we were talking about with the vertical shift, we were using the y-axis as our gauge of what's going on here. With a horizontal shift, we're going to take a look at the x-axis. So in this case, we notice that the sine graph crosses at pi, because the sine of pi is 0. So we want to find out where that 0 point is. Well, over here, we noticed it's moved, wait a minute, there's pi. So we notice it's moved to the left, but wait a second, this is just bizarre because here we have a plus. I would have thought a plus means moving to the right. It's actually the opposite, which can get a little confusing sometimes, but if you see a plus, that means our shift is going to the left. And how much is it going to the left? Pi over 4. So what we had here was pi over 2 at this point, and we have pi at that point. So what's in between those two is where this now is crossing over, which is 3 pi over 4. Another way you could think about that is if we have 1/2 here and 1 here, 3/4 is right in the middle of that. So we shifted to the left, and we shifted to the left pi over 4 units. So again, this one tends to be a little tricky just because the sign is counterintuitive, meaning if it's plus, normally you would think that means go to the right. In this case, it means go to the left. So let's take a look at our cosine graph now. So once again, let's pull up our calculator. Let's just graph the cosine of x. And here comes our rudimentary cosine graph. All right. Now, I'll pull it up again. We're going to look at this cosine of x minus pi over 3. Now, ordinarily, again, I'd think minus means we're moving to the left, but after learning in that last slide that the plus was opposite direction, I'm going to say that this one's probably going to shift to the right. Let's see if I am correct. We want pi over 3. And we graph it. So let's pull it on the board here. So again, we have this minus sign, which we normally think is left. It's actually going to mean that we're shifting to the right, and the amount we're shifting to the right is this pi thirds. Well, let's try and find a point and see if that is true. So in this case, we notice here's a 0 point here. That's at pi over 2. Well, where's the 0 point here? Well, that's what we don't know. Well, here we have pi over 2, and here we've got pi. So what's pi over 2 plus pi over 3? And again, I'm saying plus because we are shifting to the right. So we're adding pi over 2 plus pi over 3. And if we were to get common denominators here, this would be 3 pi over 6 plus 2 pi over 6. And our new location is 5 pi over 6. And that's where this question mark is here. That's where we're having our new 0. So we see that the minus sign does in fact indicate to the right. Now, if we were to look at this problem down here, this third one, let's just talk about what's going to happen. We don't need to graph it because we've already learned all these things. We're smart enough to know. If we have a minus here, which way is that going to be? That's going to be to the right. And how much is it getting shifted to the right? Pi over 2 units. But wait a minute, we have one other thing as well. We have this 4 stuck in front of the sign. From section 4.1, we recall that that means that the amplitude is getting increased by a multiple of 4. So our original amplitude that goes from -1 to 1 will actually go from -4 to 4. All right, so to kind of draw conclusions about this, what we can say, our phase shift or our horizontal shift is the amount the graph is shifted to the left or right. And we can shift it to the left or right by adding or subtracting within the function, meaning inside those parentheses. So again, if we had something like the sign of x plus pi, something along those lines. And again, remember, plus means to the left, minus means to the right, which is normally opposite. If we take a look down here, we have now touched on 4 different areas of movement. We've talked about both the sine and the cosine. In section 4.1, we addressed A, which is the amplitude, and we know that's the one that's out in front here being multiplied. We touched on B in section 4.1, which looks a little bit different here. We talked about multiplying inside the parentheses. Well, it's actually multiplying inside the function, and we're still considering this inside the function. So this B here and here, those are the period changers. Now, in this section, we talked about vertical shift, which is our C. Notice again, that is outside the function. That is outside the parentheses and outside the function in general. And then we talked about D, which is the phase shift. And that one is inside the parentheses, inside the function. And again, just a reminder, opposite of the sign. So minus is to the right and plus is to the left. So that is the first video of section 4.2.